Welcome back to another Text-Based Tuesday. I've been looking forward to recording this video a lot. So last time, Text-Based Tuesday, we played through Ord, real simple, text-based adventure game, very straightforward design, something that has a lot of potential from a storytelling capacity, I feel. And given the simplicity, it should be fairly straightforward to put together not really a clone, not just a clone, but an entire engine whereby we can define new games. And so this week we're going to set forth some loose requirements around what we want the engine to do. We're going to do a little technical design. We're going to try to do this all on a whiteboard here. So let's think about requirements here. So we're not going to do, user story type requirements or anything like that, but just remembering back to what the game was, some of the features, some of how it worked. What do we want ours to do here? The game started off, and you were essentially in this opening state, and you were presented with a message, and you were presented with a bunch of options. And when you clicked on one of these options, this would take you to other states, right? And each state effectively looked the same. You had a message, a couple options. We can use this to sort of inform our model of how we're going to talk about the game. So we've got states. We'll call these transitions. When the game opens, a player starts a game in the start state. And then as we talked about, a state presents we'll say this is the description, and it also presents a list of the transitions. These are our transitions down here. And in Ord, it looked like you only had two options, but there's really nothing stopping us from having any number of options for a particular state. I'm really making a mess of this up here. When a user clicks on one of these options, one of these transitions, when they select a transition from the list available to them, they should be taken to the next state. And so we essentially have a state tree here is what's happening. And eventually you reach certain points where there are terminal transitions. So we'll call this a terminal transition. So a transition defines how a user moves from the current state to a new state. And so we can say that the transition, when a user clicks a transition, they're taken to the next state defined by the transition. Something we saw in the game was some of the transitions you would select an option and it would always take you to the same next state. And that was probably the vast majority of the transitions. It was fairly straightforward. Some of the transitions, however, such as very early on in the game, there was the stay at home option. And when you hit stay at home, it seemed to just pick from a few different things. There was one where you were drinking coffee. There was one where you were watching TV or reading a newspaper. It seemed like it was just picking randomly from a pool of options. And so this gives us the idea of different types of transitions that have different ways of defining what state is the next state. And I think for us we can settle on two, but as we look at the design for this, thinking about future extensibility of the solution here, we had the notion of a transition type. We'll model that in how we actually build this thing so that new types can be added on in the future to provide additional behavior. So we'll have simple transitions and we'll have random transitions. technically, if these were going to be the only two types that we ever had, we could get away with just having a single type, which is the random type, and then defining just one transition in the pool would obviously have the same behavior as the simple transition. However, we are modeling this for extensibility, which is always important when you're thinking about software design, is not just what is the problem today, but what might the problem be tomorrow. Even though I don't know how to code for the problem tomorrow because I don't know what the problem is yet, I want to design in such a way that I can build out the solution in the future without overhauling the solution. So this is good. So we've got this notion of types. We'll have different transition types. If we need a third type in the future that has some other behavior, we can do that. All right, so a couple other things we want to account for. One was what I'll call the UI embellishment. So there were certain states where we saw in the game it would start raining, or when we were in the dungeon the lights would dim, or there would be lightning and things like that. So we've got this notion of states, not just having a description, but also having, we'll just call it information or metadata that describe other aspects of this state. And to the game engine, the portions of the engine that we're worried about right now aren't going to do anything with that metadata, but it gives us the ability to return the entire state object. Then the front end, whatever the front end is, can decide what, if anything, it wants to do with this additional metadata. So we got a description, a list, because we want it to be ordered. Remember, classic interview question, difference between a list and a set. Without getting too much into a nuance, lists are ordered, sets are unordered. That's one classic difference. Probably the more canonical difference is that lists can contain duplicates, whereas a set is implicitly does not have duplicates. So that's sort of a hybrid of requirements and some high-level design, but now let's get into tech design. We have the notion of state, obviously. We've defined state to have a description, which is going to be a string. We've defined it to have transitions, which is going to be a list of transitions. We've defined it to have metadata, which is just going to be a string map. And that's it. That's all state is. Next we got transition. Remember, we've got different types of transition, and we're sort of designing this for JavaScript. And so I'm not necessarily going to directly introduce notions like interfaces and stuff like that. Transition by itself has a title, right? Now I'm just going to say description here too. And it has a type. And then we can define our two types of transitions. So we have simple, and this is going to extend transition, so I'm not going to redefine the fact that it has a description and a type. But in addition to those two, it's going to have a next state, and then we'll have random transition. And then this is going to have next states. Along with all of that, then we have the notion of a game. We'll say a game has a title, game has a description. More importantly, game has an initial state. I guess that's it, right? Initial state. All right, so these are sort of our object models. If you think about, the fact that this is an engine, we want to be able to define new games in some ways. So you can imagine that we're defining these games in like JSON or something. You can imagine that we would have some sort of ID, title, description, initial state. Now here, initial state is going to be some sort of state identifier. We wouldn't actually put probably the entire state object in here because we would define all of our states in a big array. And this is going to be a list of transitions. But again, here, we would probably do an ID. So we do like, T123. And then you would have additional transitions here. And then we'd have transitions. So again, this is just pointing to a string identifier. And that's it. That's the whole thing. And so you see this can all be persisted nicely. This gives us the ability to reuse transitions. You could have the same exact transition showing up in multiple as an option in multiple states without having to duplicate that. You can use the same state in multiple transitions. All right, so this gives us the structure, but then we need, what methods are we going to have here? So, well, we could say it's going to have a start method, but we really almost don't even need that because we have initial state as an attribute. If the game is going to be sort of our persistent object that's holding on to the state, we can just say that this has get state. And this is going to give us back whatever the current state is. Game also has an apply method, which takes a transition. And so what apply is going to do is it will perform the transition and return from this a state. So we would return whatever the state is that we've transitioned to. This really seems like it, right? We need to get the state and we need to apply transitions. And much else beyond that is the concern of the client, how it wants to present the state, how it wants to present the transitions, how it wants to give the user the affordance to actually select a transition. The transitions, we'll say these have an execute method, which returns a state. And the state, does the state have any methods? I don't think so. Beyond, if we wanted to put things inside of getters instead of just getting attributes. So these are all, the idea here is that these should be technically immutable. So we won't have any setter methods, although this is, of course, JavaScript. So I'm not going to jump through any of the hoops necessary to actually create, private variables or anything like that. Because again, I don't really care. And I'm trying to keep this simple. But yeah, the state doesn't need to do anything. The state's just going to be a data structure. Simple transition and random transition, these will be, so the difference between these two is going to be the logic of the execute method, but they still are just going to have the execute method. Now there's a question of, as this game kicks off, if I instantiate the game, so we might say we have a game factory that's going to take this JSON structure and know how to deserialize it into a game, now how to take it and create a game object. There's a question of how we want to maintain these states and these transitions. For instance, do I want to try to go through when the game starts and actually instantiate objects for all of the states? Do I want to do the same for transitions? Do I want to do that lazily? So when a player actually reaches a state, that is when the state will actually be made manifest. Part of that is going to beg the question of whether when I'm returning next state, these when I'm returning state from execute, am I returning a state for real, a state, or am I returning a string that something else is going to have to turn into a state? So there's a couple ways that we could do this. Let's say we didn't want to instantiate everything up front. I don't think we want to instantiate everything up front because that's going to cause, these games aren't going to be so massive that it's really going to be an issue, but let's say you had 50 million states in your games. That's going to be a significant memory footprint, a significant cost to initializing the game if you have to instantiate this entire structure. Let's say there's going to be a notion similar to the game factory. We're going to have a bunch of factories. We're going to have a game factory. We're going to have a state factory. We're going to have a transition factory. Now let's start by looking at transition because I think we're going to kind of work our way backwards here. So if we can answer our questions for transition, I think that's going to answer the questions for the rest of this stack. So transition factory, if this needs to make a transition, it needs to know about the set of possible transitions. This is going to map transition types to, since we're already calling this transition factory, we'll call this specific. Oh my gosh, I'm taking up so much space here with this. Transition factory. And so what this is going to let us do is and I think this is it for just transition factory, because all this is going to do then is it's going to take this object and it's going to look at the type. It's going to see if it has something in this map. If it does, it's just going to pass the object to this factory and return whatever. So let's think through this. So this thing is going to take this object, ID and type, fine. Next state, if we decided at this point that we wanted to instantiate the next state, we would have to have the full state object. We'd have to have this whole thing up here. And to produce this whole thing up here, we would have to have the state factory down here. So we would have to be handing the state factory to the transition factory. For state then, as we were constructing the state, we would run into the same question, which is when I see transitions as I'm constructing the state, do I construct each of the transitions? If we constructed all of the transitions for the states and we constructed all of the states for the transitions, then the moment that the first one of these gets constructed, all of these are going to get constructed anyway. So I don't think we want to do that. Let's say we were doing it totally lazy. So we said get state, and let's say it's just not even initialized yet. So the game would need the state factory to be able to produce a state object. So initial state is going to be a string. So this whole thing is going to this game is probably going to need, maybe not in what we would consider the quote-unquote public-facing API, but behind the scenes, it's going to need this registry of states by ID, transitions by ID to be able to be able to do anything. And, we could package this inside of some other object or something, but at the end of the day, it's going to need this list. So let's just say it's going to have these lists. It's going to have this list of states. It's going to have this list of transitions in the game. And so we call get state. It's able to construct the state. The state object is going to have a list of transitions. At root, those are going to be strings. And so when get transitions is called, that's when we actually want to instantiate those transitions. But we don't necessarily want to instantiate the states inside of those transitions. And so when execute is called, when this apply gets called, all this is going to do is it's going to run the transition logic. It's going to change the pointer of the current state to a string. So that's always going to be a string. It's not going to point to an actual state. It's just pointing to an identifier. So here we can just make a couple notes. So the game is going to have the registry of all the states, all possible states and transitions, and the ability to construct those, which means we're, at the end of the day, we're going to hand it. Either we're going to hand it the factories, or we'll create, call them state registry and transition registry objects that hold on to these lists, but also have the ability to do things like get state by ID. Maybe that's what we'll do, because that may open us up for some easier work of, caching previously manifested states or anything we want to do around performance of instantiating the states. All right, so the transitions execute method returns the string of the next state. What this means is that the state transition registry will actually take as, or the state registry will actually take as input the transition registry. So this gives us our sort of overall design. The game factory is going to take this big JSON object. We're going to create the game. We're going to create a state registry and a transition registry. Those are going to be handed these state and transition lists. They're going to have the ability to sort of lazily instantiate these things as needed. The state registry will also be handed the transition registry so it can create transitions. And then the game, this has a get state method, and the get state method is going to call upon the state registry to instantiate, to get a state for the ID. And then it's going to have an apply method. Apply method takes a transition, just calls execute on it, gets the string ID of the state, probably just sets that as the current state, and then returns a call to its own get state, which will just instantiate the state, or it'll get it out of the registry. It's not going to instantiate it. And that's really it. We'll say everything else from there is really on the client to figure out. Got a little sloppy over here, but I think we got what we need to put this together. And so next TechSpace Tuesday, we're gonna code up the engine portion in JavaScript. Hopefully, we'll actually get to the point of we'll do it as a module so that we can code this up. We can test it. We'll actually do some testing of it in Node. We'll just test it with Mocha. Get some automated testing in there. So we'll exercise the engine in all of these various classes. Using Mocha essentially as the client, quote unquote. And then the TechSpace Tuesday after that, well, the one after that, we might actually play a game, but eventually we'll build a little React client to actually run this thing in the browser. And as I mentioned, I'm going to be putting all this up on GitHub. So as the code goes up, there'll be links in the description of the code or the videos for the code to where you can find this, pull it down, play with it. I'd love to see, if you do play with it, what kind of stuff you're creating, what kind of ideas you have to extend the thing. And yeah, we'll just keep adding on to this. I think this will be a fun little project to kind of follow along in this series of videos. So thanks again for watching. If you like this, tell a friend about it. We're just trying to get the channel off the ground, so it would be really appreciated if you spread the word. If you like what you see here, like and subscribe. Follow us on Twitter at Taco Pizza Papa. Check out some of the other videos on the channels. Me playing some games in ridiculous ways, sometimes with my children. And until next time, don't forget to eat your vegetables, which is a terrible send off, but it's, we'll play with it. We'll workshop it.